Come on guys, today we are going to learn persistent storage, that is PV and PVCs in Kubernetes. So by default, Kubernetes stores the data inside the pod's file system. But we know that pod is ephemeral, means it is temporary. So if a pod restarts, all the data is lost, it's gone. To avoid that in Kubernetes, we have persistent volume and persistent volume claims, PV and PVCs. Here first we can create a PV, then we can create a PVC, then we can mount that PVC to a pod. So let's create a PV first. For that I can create a YAML file, vi p.yaml. So in the YAML file, as usual, we have AKMS, API version, kind, metadata, and spec. And we are going to create a PV. So kind will be the persistent volume. And I'm going to name this PV as my PV. And in specification, I define the capacity, that is the storage capacity, that is 1 GB. And the access mode is read write once, means allows one node to read write. And the reclaim policy is return, means keep the data after the PVC is deleted also. And the storage class name is manual. And path I'm going to mount is mnt/data. This is the path on the node where the data is stored. Let's save this YAML file now. Let's apply this now using kubectl. Apply -f p.yaml. PV is created now. I can get the confirmation by running kubectl get PV. So my PV is created here. So next step is creating the PVC. For that, I'm going to create one more YAML file, vi pvc.yaml. So here also AKMS, and the kind will be persistent volume claim, that is PVC. And name of the PVC is my PVC. And in the specification, access mode is read write once. And in the resource, I have the storage 1 GB. And the same storage class name, that is manual. Let's save this YAML file now. Let's apply the PVC using kubectl. Apply -f and pvc.yaml. So PVC is created now. We can verify that using kubectl get PVC. So my PVC is created here. So next step will be use this PVC in a pod. For that I am going to create one more YAML file, vi pod pvc.yaml. Here also I am going to use AKMS, and the resource is pod. So kind will be the pod, and the pod name is PVC pod. And in specification I am going to declare the volumes. Volume name is storage, and I am going to use PVC, persistent volume claim. And the claim name is my PVC name, that is my PVC. And for the pod I am going to use engines container, and for the container I can define the volume mounts here, and the mount path will be this one, and the name of the volume mount is storage. That's it. Let's save this YAML file now. Let's apply this YAML file, kubectl apply -f pod pvc.yaml. So pod is created now. I can verify that using kubectl get pods, kubectl get pods. PVC pod is created, but it has a one error here. And when I run kubectl describe pod, I'll get these errors here. You can see failed to mkdir mnt/data. So mnt/data folder is not able to create. Maybe manually we can log into those nodes and create these particular folders. I logged into one of the node and I tried to create a data directory inside /mnt. I got the same error here. The issue here is I can't create a directory inside root file system. So here instead of host file, I'm going to use disk provided by the GCP only. So I'm going to create a new disk using gcloud command now. So now the disk is created. I can use this persistent disk now. Let's modify the pv.yaml now. So instead of host file system, I'm going to use a gc persistent disk here. And the PD name, that is persistent disk name, is my pv disk. And the fs type is ext4. Let's save this YAML file now. Let's apply this now. kubectl apply -f p.yaml. I think still previous PV is not deleted. So I'm going to give a different name here, my PV PD. And let's save this YAML file. And if I run kubectl apply again now, so now the new PV is created. Let's modify the pvc.yaml also. Here the storage is 10 GB, and let's modify the name of this PVC also, my PVC PD. And let's save this YAML file now. And if I apply this pvc.yaml, new PVC is created now. Let's modify the pod YAML also. Here claim name will be my PVC-PD. Then let's save this YAML file now. Let's apply this YAML file now. Now the pod is created, and if I run kubectl get pods, the PVC pod is created and the status is running. So host path mounting is not working. So we created a persistent disk and we attached that. Now let's verify that using kubectl exec to that particular pod, and let's run df disk free command. You can see /data is attached now, and it is almost 10 GB, that is 9.8 GB. This is /data because in the YAML file we have mentioned as /data. In the pod PVC YAML file, you can see mount path is /data here. That's why it is attached to /data mount path. Let's create a file in that particular path, that is in /data path. For that I'm going to run kubectl exec, and inside the file I'm going to write persistent data. Let's run this now. For some reason in git bash it is not working. I am using command prompt for this particular command. Let me run this in command prompt now. So it added the content now. Now let's delete this particular part and let's see whether it's able to persist the data or not. Let's enter this command now. PVC pod is deleted now. Now if I run kubectl get pods, I don't have any pods here. Let's apply the pod yaml again. So it should create one more pod now. If I run kubectl get pods now, kubectl get pods, PVC pod is created now. Now let's verify whether the data is persisted or not by running kubectl exec and the cat this particular file path. If I run this now, I get the same content here. That means data is persisted even after deleted the pod. So that's how we create PV and PVCs and using those PVCs inside the pod. So here instead of manually creating the PVs, we can dynamically provision those PVs. Let's see how this works. For dynamic provisioning, we have to create the storage classes. So let's first see what are the storage classes are available. For that, I can run kubectl get storage class. Here I can use premium ROW, standard and standard ROW. These are the storage classes available in GKE. So let's create a PVC using dynamic provisioning. For that, I can create a YAML file vi dynamic PVC dot YAML. Here in this particular PVC, I'm going to use storage class name as standard-ROW instead of manual. This is GK's default storage class name. Let's save this YAML file now. Before applying the PVC, let me run kubectl get PV. Here I have only one PV, that's my PVPD, and this PVC I manually created earlier. Similarly, if I run kubectl get PVC, I have only one PVC, that is my PVCPD. Now I can apply this particular dynamic PVC YAML file. If I run this, it should dynamically create the PV also. Here I have not created any PV for this manually. So dynamic provision should happen now. Let's run this now. If I run kubectl get PVC now, you can see my dynamic PVC here and it's the storage class is standard-ROW. You can see it is stuck in pending from the last 4 minutes. So I run kubectl describe PVC, my dynamic PVC, and I will get some error message here waiting for first consumer. And if I run kubectl get storage class also, I can see for premium ROW and standard ROW, I can see the message here waiting for first consumer, but standard I can use immediately. So I will use the standard class now instead of standard ROW. Here I will change the storage class to standard and the name is my dynamic PVC standard. And let me save this YAML file now. And if I run kubectl apply now, it created a PVC now. And if I run kubectl get PVC now, kubectl get PVC, it created my dynamic PVC standard now, and I have the volume here. Now if I run kubectl get PV, I should have two different volumes. One is manually created, another one is dynamically provisioned. Kubectl get PV. You can see this is the first PV that is created manually, and this is the dynamically provisioned PV. And the storage class is standard. This is how we can dynamically provision the PVs. So manually creating PV every time is not required. So that is about PV, PVC, and using the PVCs inside your pod. Also, we saw data is persisted even when the pod is deleted. That's how we can use PV and PVC for data persistence. Also, there is no need of manually creating the PV. We can dynamically provision those PVs also. So that's it for today. Subscribe and check out other videos too and keep learning.